Okay, so let's look at this paper that is from 2021 double E, and what we are looking is the linear algebra question. Right, so far I have done for various paper that you can look at anytime for your revision purpose. Right, so I have done for mathematics, statistics, computer science, EC, and now I am doing for the double E. So for revision you can go through that question. Those are good questions. And let's look at this question number 1, that is from linear algebra, and what it is asking that p and q be the real numbers such that p square plus q square is equals to 1. So we have given this relation, the eigenvalue of the matrix this R. So we have been asked that what is the eigenvalue of this matrix. So if you write the characteristic equation for this matrix, so let's suppose that lambda is the eigenvalue, then how we can write the characteristic equation for this matrix is the lambda square uh, minus lambda times the trace of the matrix. So let's call it that matrix A plus uh, uh, the determinant of this matrix A, and that should be equal to 0. So here if you find the trace, that will be 0. So lambda into 0 is, so this, you will add up these two, that will be 0, right? And the determinant will be minus of p square and minus q square is equal to 0. From here what you can see that it is equal to lambda square minus of p square plus q square is equal to 0. And from here you can say that p square plus q square is equal to lambda square. And if you look at this relation, then you will find that lambda square is equal to 1, and from here what you can say that lambda is equal to plus minus 1. Right. So we here have this lambda, this is what the eigenvalue. So the correct answer for this is 1 minus 1. Okay, now let's look at this one more question that we have is question number 38, I think. 37, 37 and 38, yes. So what we have been asked that let A be 10 by 10 matrix such that a to the power 5 is null matrix. So you see that you can, from this statement, what you can say about the matrix A, right? This is nothing but what kind of matrix poses this type of property, that you can let me know in the comment section that this is the some special kind of matrix, and we have the name of that kind of matrix. And from this statement what you can say that what kind of matrix is that, let me know in the comment section. And I be the 10 into 10 identity matrix, the determinant of a plus I is. So what we have given that a to the power 5 is a null matrix of 10 by 10, right? So all the elements are 0 in this matrix. So if this matrix A have eigenvalue, that is lambda 1, lambda 2, lambda 3 up to lambda 10, then if I ask you that what will be the eigenvalue of this a to the power 5, so that you can look through the, what I can say, that like you can decompose this matrix to some diagonal form, right? And if we have this a to the power 5, then this matrix will be in this form, right? So all the lambda, all the eigenvalue, this is nothing but the diagonal matrix. So and at the diagonal position all the eigenvalues are there, so all the eigenvalue will get powered to 5, right? So it will be power to 5, and lambda 3 will be also same as lambda 10 will be also power to 5. And what we have given that lambda 1 to the power 5 is equal to 0, right, from here. So what you can say about lambda 1 is 0. Similarly, what you can say till lambda 10 we have 0. So what you can say about the eigenvalue of this matrix A is all the eigenvalues are 0. Right, now what we have been asked is the determinant of this matrix. So determinant of A plus I is equal to what, right? So you see that we can decompose this matrix A. Then what we are going to have, we can decompose this matrix A, right? So if you decompose this matrix to S, let's say lambda S inverse, right? So this lambda, that is the diagonal matrix, is going to have all the diagonals will have 0 element, right? 0 elements at the diagonal position, right? And here it will be 0, here it will be 0. Now if I ask you that if you decompose this A plus I in diagonal form, then let's say that you are decomposing in some P lambda, you can say lambda 1 times P inverse. So what we are going to get at the diagonal position? So at the diagonal position what you will get is the 1, right? Because 0 plus 1, that is going to be 1 all over the place. And if I ask you that what will be the determinant of this matrix, so it is nothing but the product of these all diagonal element, because these all are the eigen value of this A plus I, right? So you can do the product, and what you are going to get is 1 into 1 into 1 10 times, so 1, right? So the correct answer for 38 is 1. Hope it makes sense. Okay, that was the two question in 2021 paper. We will look at 2022.